Hello everyone, welcome to my YouTube channel. This is the lesson number 3 of differential equation. In the previous lesson, we have completed geometrical meaning of solution of differential equation and formation of differential equation. We have done so many examples on formation of differential equation, and today we are going to cover method of solving differential equation. There are two types, type 1 and type 2. Type 1 is solution of first order differential equation, and type 2 is second order differential equation. Okay, so let's get started. In type 1, okay, suppose we have the form of differential equation dy by dx is equal to f of x, or dy by dx is equal to g of x or g of y, or dy by dx is equal to f of x into g of y. In type 1 we have three type of problems. One is dy by dx is equal to f of x, dy by dx is equal to g of y, or dy by dx is equal to f of x into g of y. Okay, so we are going to cover all these forms. So first form is dy by dx is equal to f of x. Okay, in this case, what is the step that we are going to solve by which we can solve this question is dy is equal to multiply this dx on right hand side. By cross multiplication method, I multiply the dx on right hand side. Okay, now I got an equation dy is equal to f of x into dx. Now we can integrate this equation on both sides. Now integrating, suppose this is equation 1 on both sides. Okay, what we have got now, integrating dy and integrating f of x dx. Okay, this is the first method. By integrating this equation, we can find the solution to this differential equation. Okay, what have we done? Just we know that integration of dy is y, and to integrate this f of x we need an integrand, or by which we can integrate this function, and that is dx, because this is a function of x. So we multiply dx on right hand side by cross multiplication method, or you can understand by to find the integration we need an integrand. So what can we do? We can do dy by dx into dx is equal to f of x into dx. Same thing, just in a different way. Okay, we have to integrate, so we need an integrand, so we multiply dx in both sides. Now this dx is cancelled, again we find the same equation. Okay, so to avoid this step, what have I done? I just multiplied by cross multiplication method. Clear? So let's have some example so that we can understand this form. Okay, in the previous lesson I have already told you that we are going to solve the questions or examples from the book Elements of Mathematics. Okay, Elements of Mathematics. So this is example number 5 of Elements of Mathematics. Okay, class 12 of the topic differential equation. Okay, now to solve this equation, our question is solve dy by dx is equal to x square plus 2x plus 5. What can we write? Multiply the dx on right hand side. To integrate this portion or to find a solution, what can we do? We have to integrate this derivative so that we can find a y. Solution means what? We have to find y. Okay, so to integrate, we multiply x square plus 2x plus 5 into dx. To integrate this function we need an integrand. Okay, so we multiplied dx on right hand side. Now implies that integrating both sides, dy is equal to integration of x square plus 2x plus 5 into dx. Implies that integration of dy is y is equal to integration of x square is what? We know integration of x power n by dx is n into x power n minus 1. Okay, now apply this formula. We have x power n is n into x power n minus 1. Okay, so what is the integration? This is the differentiation of function x power n. What is the integration? X power n into dx integration will be x power n plus 1 by n plus 1. Okay, we have to remind all the formulas. Okay, so x power n derivative is n into x power n minus 1 and integration of x power n is x power n plus 1 by n plus 1. Okay, we already know about this. So x square integration will be x power 3 by 3. N plus 1 means 2 plus 1, 3 by 3 plus 2 into x integration is x square by 2 plus 5 is constant. So dx integration is x plus c. What is c? C is the integrating constant, which implies that y is equal to x cube by 3 plus 2 is cancel, x square plus 5x plus c. This is the solution. Okay, this is the solution of this differential equation. What have we done? We only cross multiply because this is the function of x and we integrate this function with respect to dx. So we multiply dx and then taking an integration we find y. Clear? Now the second type. What is the second type? dy by dx is equal to g of y form. Okay, to integrate this function, this is the function of y. To integrate this function we need integrand as dy. Okay, so if we take this function on left hand side, it will be dy by gy is equal to dx by cross multiplication, and gy is in right hand side, so in left hand side gy will be divided and dx is multiplied in right hand side. Okay, so now this is an equation. Okay, now to find y we have to integrate both sides. Implies that dy by gy integration is equal to dx integration. Now this equation will give us the solution to this differential equation. Okay, to solve gy or to integrate gy we need the integrand dy. That's why we take this variable of y or function of y in left hand side and dx as right hand side. Now I can easily integrate this function. Clear? So let's have some example. Now this is an question. Solve dy by dx is equal to 10y. Okay, to solve this question we know the right hand side will be is the function of y. So what can we do? Dy by 10y is equal to dx. Okay, I can write in this way, which implies 1 by 10y is, we know 1 by 10y is cot y. So this is cot y dy integration is equal to dx integration. This is direct formula. Cot y integration is ln sin y is equal to dx integration is x plus c. C is the integrating constant. To find the solution to this differential equation, we have to do y variable in one side and x variable in other side. In the first form also we have done x variable in one side and y variable in other side. Here also we have done x variable in one side and y variable in other side, so that we can integrate easily. Okay, clear? Now this is the solution to this differential equation. C is the arbitrary constant or integrating constant. So this is a general solution. What is general solution? What is particular solution? We have already covered in lesson number 1. Okay. So if you have any confusion on these solutions, so you can watch my lesson number 1 video. Okay. Now let's move. Third form is dy by dx is equal to f of x into g of y. When there is only function of x, we multiply this dx in right hand side to find the solution. Or when we have only function of y, we divide gy on left hand side to find the solution. After integrating, we can find the solution. But in this case, both the function are by multiplied form. So what we have to do? We have to do the x variable in one side and y variable in other side, which implies dy by gy is equal to f of x into dx. Now x variable in one side, y variable in other side. Now integrating both sides, we can find a solution. Okay. This is called the variable separable method. Okay. This is called variable separable method. Clear? Now let's have some example on this form. Now this is the question. Dy by solve dy by dx is equal to 2y by x square plus 1. This is a differential equation, okay, which is variable x and variable y. What we have to do? We have to find a solution. To find the solution, what can we do? We have to separate the variables in both the sides, which implies y in one side means dy by y is equal to 2 is the constant, so there is no issue if 2 is on right hand side or on left hand side, into dx divided by x square plus 1. Okay. Now the whole left hand side is on variable y and whole right hand side is on variable x. Now we can integrate both sides. Implies that integration on left hand side will give ln y. This is the direct formula. 1 by y dy integration is ln y, and 1 by x square plus 1 integration is what? Into dx is tan inverse x. ln y plus c, tan inverse x plus c is equal to 2 is the constant. So we can take the 2 as outside of integration. Now integration of 1 by x square plus 1 into dx will be tan inverse x plus c. Clear? Okay. Now this is a solution to this differential equation, and this method is called variable separable method. Okay. Next. Now another form of differential equation is of the form dy by dx. This is the fourth form. Dy by dx is equal to f of ax plus by. Okay. In this case, we can't separate ax and by. We can't separate a function of x on one side and function of y on other side. We can't separate these variables. In this case, what we can do? Let ax plus by is equal to v. We put ax plus by is equal to v to find the solution. Okay. Clear? So now I have some example to understand this logic. Our question is solve dy by dx is equal to x plus y square. Okay. In this equation, we can't separate x and y individually. So what we can do? Let x plus y is equal to v. Now differentiating both sides, we get 1 plus dy by dx is equal to dv by dx. We differentiate with respect to x. What we have done? We differentiate with respect to x. which implies that instead of dy by dx, what I can put? I can put dv by dx minus 1. Okay, what I can put? dy by dx is equal to dv by dx. 1 is on left hand side, so by taking it on right hand side, I got dv by dx minus 1. Okay, this is equation 1. Now, okay, put in equation 1. Now putting in equation 1, what can we get? We get dv by dx minus 1. This is the value of dy by dx. Okay, what is the value of dy by dx? dv by dx minus 1. So we put dv by dx minus 1 instead of dy by dx is equal to, for x plus y, what I can put? I can put v, which is equal to v square, which implies that dv by dx is equal to v square plus 1, which implies that now this is the function, or this is the newly formed function, which is of the form v and x, or which is of the variable v and x. So what can I do? dv by v square plus 1 is equal to dx. Okay, what is it? I can apply variable separable method. Okay, so because I can separate the variables, so I use variable separable method. Now integrating both sides, what is this formula? I have just told on the previous example that this is tan inverse v. Okay, we have already taught on integration, which is equal to dx integration is x plus c. C is the integrating constant or arbitrary constant, which implies that tan inverse, instead of v, what I can write? X plus y. Tan inverse x plus y is equal to x plus c. This is the solution to given differential equation. We have already know, if we use a substitution at last of the solution, we have to again do the back substitution. For substitution, at last we have to do the back substitution to find the answer. Okay, so what can I do? I have already done that if x plus y is a non-separable function, we can't separate x and y. If we can separate, then we separate y on one side and x on one side. But if we can't separate, then what can we do? We can take x plus y is equal to v, or that function that given on the questions are taken as v. Now find dy by dx to put on this value. So I differentiate on both sides. 1 plus dy by dx is equal to dv by dx. So dy by dx is equal to dv by dx minus 1. Okay, now put this value on equation 1, and now I am solving this question as dv by dx minus 1 is equal to, instead of x plus y, I put v. So v square. Now dv by dx is equal to v square plus 1. Now I can apply variable separable, because I can replace v square plus 1 in dx and dx on right hand side by cross multiplication, because I can separate the variables. So I separate the variables, and by taking integration I got the answer. Okay, so in this lesson we have covered this method of solving differential equation type 1. In the next lesson, we are going to solve, or we are going to cover type 2. Okay, in the next lesson we can solve type 2, or we can cover type 2 second order differential equation, and in this lecture we have covered type 1. Okay, thanks for watching.